Hey everyone, welcome back to my YouTube channel and I hope you all are doing well. So in our previous video we saw what is JDK, JRE, JVM and all. So today we are going to learn about JVM architecture. How does JVM actually works? So let's get started. Let's say we have this piece of code, okay? How do we compile it? We compile it using the compiler javac test dot java. Then this creates a test dot class file. This dot class file is not machine code, it is a byte code. It is a byte code. So to run this, what do we do? Java test. So from now JVM starts working. We can see that JVM has three main parts. First is class loader, then we have runtime areas, then execution engine. So we will see each and every concept one by one. So firstly, let's get started with class loader. What is class loader? Class loader. It loads dot class file, which is a byte code, into JVM. When you run Java test, when you run this command Java test, JVM says, okay, where is test dot class? Where is test dot class? Test is what? The name of our Java class. So class loader will do three things. Firstly, loading, linking and initialization. So what is loading? Loading loads dot class file into memory. It loads dot class file into memory. So there are again three types of class loader. Firstly, we have bootstrap class loader. It loads core Java classes, like we have java.util, java.lang. If you don't know these imports, don't worry, we will see these imports in our future videos. What does lang mean, util mean? Okay, so example like string, system, object, all these are loaded by bootstrap loader. Next we have extension class loader. Extension class loader was there in JVM in Java 8 and earlier versions. From Java 9 plus onwards, extension mechanism is removed or deprecated. It is replaced by Java module system. I am telling you extension class loader because it is being asked in interviews. These are extra libraries provided with Java, not code, not your own code. In short, extension class loader loads optional Java libraries. If the file is not found in bootstrap, then it will check for extension class loader. If not, then in application class loader. Then now we have application class loader. It loads your classes. Yeah, the class is written by you, by developer, like test.class or anything like myapp.class. So this is what class loader do. This is this was all about loading. Now let's go further about linking. Linking has again three steps. First is verification, then we have preparation, then we have resolution. So what is verification? Verification checks bytecode is safe, there is no illegal access, there is no memory corruption, it prevents from virus or hacking. Verification is needed because bytecode may come from internet, could be corrupted or malicious. JV must protect operating system and memory. So this is why verification is needed. What JVM checks in verification is that bytecode format is correct, there is no illegal memory access, there is no stack overflow or underflow, that then data types are correct, no illegal casting. Okay, then the question in your mind can come like, then what compiler will check? Java compiler checks syntax errors, type mismatch, variable declarations, method signatures, and access modifiers. JVM verification checks bytecode, not Java source code. Compiler checks for Java source code, and JVM verification checks bytecode. So it assumes like I might receive bytecode from anywhere. Bytecode may come from network, decompiled and modified class files, or non-Java compilers or malicious tools. So JVM must recheck for safety. So now you can link that why we say that Java is a secure language, because there is verification at every level. Now we have preparation. Preparation allocates memory for static variables. It sets default values. Like for example, if we have int x, then in preparation value becomes x is equal to 0. It sets default values. Okay. Now what is resolution? Resolution converts symbolic references into direct references. Let's take an example like we have system.out.println. JVM finds where exactly println exists. So this is what resolution is. Now we have seen what is loading, linking. Now we will see what is initialization. In initialization, static variables get actual values and static blocks execute. For example, like we have static int x is equal to 10. So this is what initialization is. About class loader, which has three types: loading, linking and initialization. In loading we saw three types of class loaders: bootstrap class loader, extension class loader, application class loader. And in linking we saw three steps: verification, preparation, resolution, and in the end initialization. So let's see what is runtime data areas. This is the most important part. JVM memory is divided into different areas like method area, heap area, Java stack, PC register, native method stack. Method area we have class name, methods, constructors, static variables, static blocks, constant pools, which are shared by all objects. Heap area stores object. For example, like we have test t is equal to new test, like this. Then T is stored in stack and new test is stored in heap. So important points about heap are that it is shared by all threads, it is the largest memory area, and garbage collector works here. Next we have Java stack. It stores method calls and local variables. Each thread has its own stack. Stack contains stack frames where each method call creates one frame, and that frame contains local variables, method parameters, return values, reference to heap objects. Now we have PC register. PC register is a program counter register, is a small memory area inside JVM. It keeps track of which instruction is currently being executed. In simple words, PC register tells JVM which line of bytecode should I execute next. Now the Java programs are converted into bytecode. Bytecode has many instructions. So JVM must know which instruction is running now, which instruction to run next. That's why PC register exists. Then what does PC register store? PC register stores address or number of the current bytecode execution. Then what does PC register store? PC register stores address or number of the current bytecode instruction. Now each thread has its own PC register. Java supports multi-threading. And example, thread 1 is running method A and thread 2 is running method B. Then each executes different instructions and need its own instruction pointer. So PC register is thread specific. Like thread 1 will point to PC register 1, thread 2 will point to PC register 2. Now we have native method stack. What is native method stack? So native method stack is a memory area inside JVM. It is used when Java code calls native or non-Java code. In simple words, if Java talks to C or C++ code, or the native method stack is used. Native methods are methods written in C or C++ or operating system specific languages created in Java using keyword native. In Java, we declare native methods using keyword native. For example, we have this. Then this native keyword is used to declare native methods. Method body is not written in Java. Then the question arises here is, why do we need native methods? Java cannot directly access hardware or use OS level features or call system libraries. So Java uses native code for file system, memory management, thread scheduling, or input output operations. For example, we have current time millis. Internally it uses native code. Then Java stack is designed for Java bytecode, Java method code. Then a native code uses different calling conventions, uses different memory structures. So JVM created native method stack to safely handle native method execution. Then the question may arise like, what does native method stack store then? When a native method is called, native method stack stores native method call information, parameters passed to native method, local variables of native code, return values, CPU register state, and most importantly, it does not store Java objects. Now we have seen all about runtime data areas. Now let's head towards execution engine. Now before understanding about execution engine, we will see what is interpreter and what is compiler. Okay, what does interpreter do? Line by line interpretation. Like it will see, it will read like class test, it will write, then it will write class test, until it will read it and compile, interpret it, it will read it and interpret it, will read it and interpret it. If interpreter finds error, suppose in this line, then it will stop over here. Again it will interpret from the first line, interpret it, then read it and then interpret it, then read it, then interpret it. So due to this procedure, interpreter is slow. And what does compiler do? Compiler checks the entire code first, that it does not contain any error. Like if there is missing this braces, then it will not compile at all. So compilers are fast due to this reason, and interpreters are slow. So we have seen that interpreter reads bytecode line by line. So it executes slowly, repeats same code again and again, due to which it has slow performance. Then to make Java faster, compilers were introduced, which improves performance. How? It converts frequently used bytecode into machine code, stores it, next time it do direct execution, which makes Java fast. Then we have garbage collector. Garbage collector automatically deletes unused objects. Like if any object is assigned to null, then now object has no reference. Garbage collector removes it. So the responsibilities of garbage collector are: it finds unused objects, it free memory, and it prevent memory leaks. I hope you understood the JVM architecture. In the case you understood, please comment understood. If you have any doubt regarding any concept, then please ask your doubt in the comment section. I will try to reply all of your doubts. And please subscribe to the channel so that it can keep motivating me to create such content in a very simple language. Thank you for watching. See you in the next video.